Hello, we are back on our lecture for the horizontal control triangulation for chapter 3. So this time, I am going to give you a sample problem on how to reduce our distance measurement with sea level. So when you see sea level, like for example, we measure the baseline. Since may topography, hindi flat yung ating terrain, and then we don't measure at sea level. When we say we don't measure at exactly on the zero level elevation since mayroon tayong height of a point. So, hindi tayo nagme-measure along the coastline in which yung shape talaga ng Earth in which zero yung ating elevation. So, we have to consider na mayroong topography and then we need to adjust or reduce our measurement into sea level. Okay. So, why we need to reduce our measurement into sea level and how are we going to reduce that? So, when you see linear measurement, so horizontal measurement, we are dealing with horizontal measurement for any triangulation network which extend over a large area. So, pag sobrang haba na ng ating baseline, for example, your ating length ng ating quadrilateral, particularly over regions of widely varying relief. Like for example, here in the Philippines, sobrang rugged ng ating terrain. And then, only limited lang yung makikita mong sobrang plain yung terrain. Must be reduced to a common vertical reference data. When you see common vertical reference data, like for example, yung ating zero, tinatawag na mean sea level o yung ating zero elevation. So we need to reduce our measurement para yung ating measurement is nag-take account talaga ng curvature mismo ng Earth. So it is important na yung position ng lahat ng na-establish natin na points are computed based yung ating reference vertical points. If these points are located on a standard spheroidal at sea level. So kung nasa bukid na natin gin-measure na distance, so we need para siyang i-refer natin sa into the mean sea level na measurement. This is commonly used datum is the plane of the mean sea level. So yung ititrate natin na plane ay yung ating location ng mean sea level. So let's say for example, i-consider natin if we take the Earth, if we divide the Earth into half, then makikita natin yung ating center ng Earth, right? So pagka-half siya, so let's say this is the center here, i-enlarge natin siya. So this is the Earth, yung projection ng center, if we consider na yung center ng Earth is center ng mass, and then doon sa ilalim, sa gitna, and then meron tayong points. So let's say meron tayong ginawang baseline. So this is baseline, endpoint ng isang baseline is point A. Tapos meron tayong isang point, this is point B. So imagine from one country to another country that is so large and so big, and yung ating network is sobrang laki ng ating network. So what will happen to the distance that we measure kung hindi natin i-consider yung ating mean sea level? Since hindi perfect shape na spheroid, hindi rin perfect na ellipsoid or spheroid yung shape ng Earth. So we need to consider yung shape mismo ng geoid, which is hindi talaga perfect. And one thing to do is we need to consider that, and then we need to reduce it into a sea level. So let's say itong line na to is projection ng radius ng Earth. Here. So ito yung radius ng Earth with respect to this point, and ito rin yung radius ng Earth with respect to this endpoint ng baseline. So pag nagme-measure tayo, this is the end of the center of the Earth. Point. If we measure this into planar, let's say this is itong plane ito, so this is the plane of the sea level. So this is the reduced one. However, yung nami-measure lang natin, since the Earth is curved, so ang yung nami-measure lang natin is itong orange na to. So this one. So imagine, if this is zero level elevation, so this is the yung geoid. This is the geoid, and this is the observed distance. Imagine the differences yung nakikita nyo dito. So this is the difference between the actual measurement, and then if we are going to reduce that into a sea level length. Okay, so sobrang laki ng difference. Hindi mo siya makikita kung sobrang liit lang ng measurement like 1,000 meter, 1 kilometer. But if we consider 20 kilometer from one region to another region na measurement, it would really affect our measurement. That's why we need to reduce our measurement from this here. Kailangan maging ganito siya. With respect na sa ating sea level at zero elevation. Okay, since ito, meron siyang, we measure this one with respect to a certain height or ng point. Well, if this is our measurement, i-reduce natin sa at zero level elevation. So how are we going to do that? So let's say this is the measured distance ng point A and point B. So this is point A and then point B. So this is our projection ng radius at A, then projection of the radius at point B. So let D, inilat natin yung ating D as the measured horizontal distance between points, yung actual mismo na measurement lang between 2 points. And then this here, we denote this one as A prime. Position pa rin to naman ng A. However, we reduce na ng length into a sea level. So we measure this. Imagine, i-measure natin siya at zero elevation. How about this A and B? Sa A and B, mini-measure natin siya with corresponding elevation. Okay, right? Like 10 meters, 20 meters, so depende sa position niya. So, what we are opted to do is, kailangan natin i-measure yung A and B with respect to the zero elevation. Like, kung ano yung datum na gagamitin on the vertical datum. Okay? So, we call this one, we denote this one as letter S. So, yung ating A prime and B prime, these are equivalent length of the line at the sea level. So sea level is at zero elevation. So we denote this one as letter S. So where S is known as D minus C. D rin siya, kaso we subtracted this one with C. Ito yung C, yung ating i-apply na correction with respect to the mean sea level. So where yung ating C, this is the correction to be applied to the measured length. And then this is, again, this is the radius. So R, ito yung average radius of the Earth at vicinity of line A and B. So isang R lang yung ating gagamitin, hindi yung R sa A, hindi R sa B. So we take the average R. And then ito, if this is zero elevation, let's write here. If this is 0 meter, then let's say, for example, this is 20 meter above mean sea level. Therefore, this A prime to A is our H o yung ating orthometric height of point A. So if this is H, this is also H at point B. So we take note that H is our average elevation above sea level of the 2 points. So since dalawang point yan, A and B, so i-average lang natin siya, hindi pwedeng isang H sa isang point, then another H for B. So we take the average. So you just add the average elevation, then divide it by 2. So that would be now the reduced, and then compute the reduced sea level length. Okay? So how are we going to, if this is H again, then this will be from the distance here to here is R minus H. So also this one here, hanggang doon sa baba is our R minus H. Now, our target is how are we going to determine the value of our C? So we already have, since given tayo ng D, given din yung ating R, meron tayong mga average na radius. Then, given din natin yung H, which is the measured elevation mismo ng point A and point B. Now, what we are looking for is we are going to determine the value of C. So, based on the illustration, we are now going to determine the value of C. Okay, now, our target is to reduce our distance, measure distance to D into S, but we need to compute now the value of C, or that will be the applied correction to the reduction. So how are we going to determine the value of C? So we can employ the ratio and proportion. So again, S equals to D minus C. So we take the ratio proportion between R. This is the whole R. Okay, so from here, B to the center is R, and the same goes with A to R is our center, and this is the R, the value of the radius. So similarly, if we are going to this triangle here with respect to H, then our C with respect to the correction to be applied. So if we measure the longer distance, mag-i-increase din yung value ng C. If we increase the value of correction, then our distance will also decrease. So that will relate na proportion yung ating distance, inversely proportional yung ating distance sa value ng C. Okay, so how are we going to determine the value of C in this portion? We can cross multiply this one, and then, okay, so that is R times C and H times D. Then divide both sides by R. Then we get only C. Right? So this will become C equals to D minus H over R. Since we divide this one by both R. Then we substitute our C to our original equation, which is S minus D minus C. So this C here will become DH over R. Okay, so this will become S equals to minus DH over R. Then we can simplify this one further since merong D dito and then we have D. Then take out natin, ilalabas natin yung D. And then remaining will be 1 minus H over R. So this will be now our working equation if we are going to reduce our measured distance into a C level na length. Okay? So, by the way, this 1 minus H over R, these are also known as, so this is also known as the C level factor. So this is 1 minus H over R. So this is also known as FCL, or our C level factor. Our FCL will change this accordingly with respect to the height or elevation of the point. Magdidepende siya kung yung elevation mo or lower or higher. So, meron tayong pre-computed na value ng FSL or yung C level factor. So, this is the pre-computed na. I think yung R na ginamit is 6370 na kilometers. If you use this R, you can probably compute this value of FCL. You can compute this one by 1 minus H over R, where yung H, it could be 150, this one, 150. It could be 150, 200, 250, 300. So, observe the value of ano, you observe the value of the reduction as the elevation increases. So as the elevation increases, yung value ng ating FSL also changes. So 499, 4740, naging 37, naging 29 na lang, naging 21. So nagde-decrease din siya along kung nag-change din yung ating value ng elevation. So yung ating 1 minus h over r, hindi siya palaging 0.99999. That's the end. So it changes. Dapat hindi niyo siya nira-round off or nira-round up. It would affect the value of the result. So kung anong lalabas sa calculator, yun lang din yung isusulat, then multiplied to d. So doon na magra-round up if you already multiplied it to d. So hindi constant yung 0.999 lang na value ng FSF. So it depends on the average elevation of points. So let's have here a sample problem. So the elevation above mean sea level of 2 points, so given yung elevation ng 2 points, let's say point A and point B, so na-determine siya through differential leveling. So we are sure na yung H na given is already orthometric. But take note, may mga problem na yung given is not in orthometric height. Like for example, ellipsoidal height pa siya. So you need to convert that ellipsoidal height into orthometric height first. So if you are doing if you're going to use the formula S equals to D times 1 minus H over R, don't forget that the H there is always in orthometric height, not an ellipsoidal height. Okay? So let's have here, in this example, meron tayong, so let's say this is station A. Meron siyang elevation na 3,613.45. Then yung isang point is masyadong mas mataas siya. Let's say this is 63615.22. And then let's say this is the center of the earth. So this is the measured distance, which is equivalent to 4,125.85 meters. Now, our target is to determine the reduced sea level distance, which is noted as our S. And we already have the given value of our R, which is 6367349 meters. So we just employ our formula, D 1 minus H over R, to determine our sea level distance. Okay, and then, so we have a given na tayo ng H1, which is 631T. Meron tayong H2, meron na tayong D, and then R. So first thing first, you need to get the average elevation. You just add the 2H and then divide it by 2. So that with the answer is, we have here 6314.54. So this is now the H, the average orthometric height. Just substitute the values to our formula. We have here. So substitute the value ng D in H. Then we come up with the answer of, kindly check on your notes, on your calculator if I present the correct answer. Let's get 4123.34. So this is now the reduced length of baseline AB. So if you are going to compare, like versus yung ating original na distance, which is 4,125.85 meters, how much is the difference around, if we took the difference between these points, around ilang meters yan? Around 3 meters. Around 2 to 3 meters. So imagine the difference na makaka-apekto sa ating distance if we really need into take account the sea level length. That's why we need to really apply this type of correction, especially if long ranges na yung ating nami-measure na baseline. It would really cause some of the discrepancy of our measurements. So if only if our target is for the geodetic control, that we need to take account the curvature of the earth, the true shape of the earth, then we need to apply reduction to sea level length. Okay? So as for the end, now again, take note that your S equals to D, 1 minus H over R. That take note, H is the average elevation of your points, and then R is the radius of the earth. Okay? And then this here, itong buong value known as the sea level factor. So this ranges from 0.99999 something, but this 0.99 is not constant since nag-change the with respect to the value ng H. Okay? So next topic will be reduction to eccentric stations. So as I mentioned in the first part of this video, so what if yung ating naging finalized, what if nakamuho na, and then it's impossible pala to put the instrument during the observation. So we need to kailangan natin mag-establish ng another point na doon tayo mag-set up ng instrument, and then i-observe lang natin yung ating true point. Okay, so we are going to discuss this one on the part 4 of this presentation. To see